Hello. We are working with snap circuits today. We're still looking at circuits and we're going to look at the parts that you're going to be using with me. Alright, we have a battery pack, and if you notice our battery pack, you can see where we're going to put the battery. So, I'm going to put in our two AA's. We also have connectors, and you can see that they are metal on the back, and they run, we have prongs, and the metal runs across. Some have 2, some have 3. We also have 4. We have a light, and you can see on the back that our light has wires. We have a DC motor that has an attachment part here. We have a switch. We also have a fan. So those are the materials that we're going to be working with. Now, the first one that we're looking at, if you look at it, I have my battery pack. And I also have my light. And we're going to make the simplest circuit that you can make today. So we have this. And when I plug it on and I snap it into place, you can see that my circuit is complete and that my light is on, and the circuit will stay on indefinitely or until the batteries use all of their energy that's stored in them. Alright, so we're going to make another type of circuit, and this time we're going to use our 3 prongs, and we're going to close the gap right here. You have an open circuit. You can see how it's not connected. When I take the 3 and I place it there, that will be a closed circuit. So I can have a closed circuit that looks like this, or I can have a very simple closed circuit that looks like that. We're going to take those apart to save our battery life. So now both circuits are open, and you can see the openings in both places. Now we're going to look ahead, and if you remember from our previous videos, we had a switch. So right now you can see that we have an open circuit. We have our batteries, our power supply, we have our light, we have our 3 prong here, and you see 2s that are going to be the connectors. So right now we have an open circuit. If I put the 2s in place, I am closing my circuit. But because of the switch there, I have to look at the switch and not just for gaps in my circuit. So my switch is in the off position, so we have an open circuit. When I close the circuit with my switch to the on position, then my bulb will come on. This is a closed circuit. Again, with the switch, when I switch it off, it becomes an open circuit. So even though you see all of the connections being made, you have to look at the switch to determine if it's open or closed. Open, switch in the off position, closed circuit, switch in the on position. And now we will cut it off again to save the life of our battery. Now, we also have our fan in place. And this time we are going to use our energy to run a DC motor, and we're going to include a fan. So I'm going to take my 2s and I'm going to close the openings in my circuit, and we need to snap them in place with our snap circuits. And you can see that my circuit right now is open because it's in the off position. I'm going to take my fan and carefully place it on my DC motor. And when I do so, I'm going to cut it on. And you can see that my circuit is closed. The batteries are supplying the DC motor with energy, causing it to run. And I will cut it off. When I cut it off, my circuit becomes an open circuit again. Now we're going to look at another type. And sometimes when we have circuits, we want to know that they are operational, that they are running. If you think of your house, when your oven is on, you will have a light indicating that the oven is on. So we have everything in place here. This currently is a closed circuit because my switch is in the off position. Now, if you're looking at it, we have our power source, we have our on-off switch, we have a light bulb, we have the DC motor, and you can see that we have made the connections. Again, it's open because it's in the off position, and I'm putting the fan in place. I'm going to close my circuit by cutting it on. And you can see that the energy is being supplied both to the light bulb and also to the fan. So you can see that it is shared, and my light bulb is not as bright as if the fan was not there, because the energy is being supplied to two things. So right now we have an open circuit. I'm going to cut it. We have a closed circuit because we have our light bulb and our fan on. When I cut it off, then we have an open circuit and the light bulb and the fan do not run. So again, right now, because it's in the off position, it is an open circuit. Now we're going to move ahead and we're going to look. So this is a series circuit. I forgot to tell you that. So this is our series circuit. If you look, there is one pathway for the energy to flow. So you have one pathway. Now we're going to look at a different way. This is a parallel circuit. And if you notice here where the light bulb is and also here where the fan is, these are parallel to one another. These lines would not cross. Now again, this is an open circuit. My switch is in the off position. Now, when our energy goes, our energy can go to the light bulb in one path. It can also go to the fan in another path. So this is a parallel circuit. And a good way to remember that is the two parallel lines you see. So we're going to close the circuit. And with my closed circuit, you can see, because this is a parallel circuit, that our light bulb is brighter while the fan is still going. That is the difference between our series circuit and our parallel circuit. So we're going to look at those side by side, and you can see the differences between the series circuit and your parallel circuit. Notice the brightness of the bulb. You can also notice the speed of the fan. The fan is much faster in the parallel circuit than it is in the series circuit, where the energy is shared in the path.